There we go. Sorry about that. The is that kind of clipping? There we go. Sorry about that. The apparently it just removed my microphone as a device because of course it did that. The only other thing I want to do is that. There we go. Yeah, I apologise. So yes, of course it wouldn't be one of my streams if when I started all of the audio just worked out of the box. It's a pretty standard feature. So what I'm working on today is I've got a big sort of permanent gazebo outside with a hot tub underneath it, which is a lot of fun. The hot tub's not there at the moment actually because we needed to take it all down because of lockdown and everything. We needed an outdoor space for sort of chilling out, so we've moved it out of the way. But the gazebo's still there. And the idea is that on the underside of the gazebo, the way that it works is it's got a bunch of panels on the top, a polycarbonate clear panels, and between them it's actually 2020 extrusion. So it's got a little T-slot running down each bar between the panels. Which means that I can then use T-nuts to screw other things on the underside. So the idea is that there's going to be SK6812 LED strips running in channels down there. And if you look very carefully behind me, I don't know whether you can quite see it, but just on the top of the... in fact, if I move the other way, just on top of the sofa, you can just sort of see like a cardboard tube running across. That's got all the LED stuff in there. I've been working on this project for quite a while, but what I'm working on today is in order to get the data from... so normally you've got a sort of single-ended signal for driving these LED strips. And of course, with 4 LED strips, I want them separately driven. That's then 4 signals. The thing is, doing that outside over the distance of meters is not very good for a single-ended signal. You tend to... Well, either the driver kind of gets a little overloaded or whatever, or you get a lot of sort of common mode noise from just random interference from outside. So what I want to do is basically have the signals go through, basically get converted into RS485. This will be in a box that's attached to one of the legs of the gazebo, and then the cable, there'll be a Cat 5e cable running out of that. That will then run up into a series of 4 junction boxes that sit on the roof. The reason for the junction boxes in the first place was that in order to feed enough power at 5 volts, because these strips run on 5 volts, in order to run enough power, I didn't want to have the 5 volt supply down the bottom because I'm actually trying to... the way I'm setting it up is all of the LEDs will be able to run on completely full brightness. So all RGBW set to 255, which is normally not something you do. Normally you power budget much lower because you don't need the brightness. However, I don't do anything without it being overkill. So in this case, I would have needed at 5 volts. I would have needed some absurd number. It was like 100 amps or something ridiculous. Yeah, I don't really want a 100 amp 5 volt supply. And the other thing with that is 100 amps over a cable that long, it would have to be like this thick. And just no. So instead what's happening is there's a 24 volt DC supply in the controller box, which will then feed 24 volts up to the individual junction boxes, which then steps that down to 5 volts using a buck converter, and then that then feeds the LED strips. Now the buck converters are all modular, so they're like just an off-the-shelf part that I bought. And I've actually assembled most of this together. It's all in a box upstairs. I started this project years ago now, but one of the things I didn't like is the single-ended signaling, which is what I was using, which I'm now replacing. And also in the existing design, the way it works is so each of the Ethernet cables have 4 pairs of twisted wire, 4 twisted wire pairs. And each signal was effectively, it was signal and ground over a twisted pair, and then that on each junction box, all I was doing was like physically separating out one wire pair. And I don't really like that because it means that I had to like hardwire it all in. I didn't have a board in there. It was all just like junction boxes and stuff. Like junction connectors, like terminal junctions, which, yeah, not very nice. So what I want is to replace all of that with effectively a board that's got 2 RJ45 sockets on it. And the idea is that the properly terminated with a connector RJ45 Cat5e cable will go into each junction box through a gland and then click into a PCB. Then that gland will be tightened to make it waterproof because obviously it's going outside on top of a gazebo. And then the additional cabling for power and for data will then come out of that box. And that board that does the splitting out is what I'm going to do today. Now, a few of you on Twitter may have already seen me talking about some design decisions on this and some annoyances with the layout. I've had a bit more of a think about it, and thanks to the folks who were chatting with me before about it. I'm trying to remember now who it was. Sorry, I'm spamming it on Twitter and just... Oh, yes, of course, David Freitag, who helped me a ton with this, and also... XSS Fox, she also gave me some cool ideas, prompted some thoughts there. So let me switch my view here. There we go. So this is some ridiculous overkill. I'll just sort of zoom in a little bit. This is some ridiculous overkill, like RS485 protection board that I was linked. I'm not implementing this. It's silly. I don't need, gas discharge tubes and metal oxide varistors and whatever a TISP is. Instead, all that's really going to be happening in terms of protection is just the TVS diodes. So the transient voltage suppressors, those will help clamp the RS485 chips that I've got can do plus minus 15 volts. So those will be clamping those at just over 15 volts. I think it's like 15.3 or something. So here's the... let's hope this actually looks all right. I apologize if some of this is looking a little crushed on stream. Just let me know, because I can't really tell because I'm on 4K and it's getting like turned down into 1080p. So I will try and be zoomed in as much as possible. So at the moment, these just headers on the edge were just sort of references for RS485, sorry, for the RJ45 connectors for the Ethernet. But effectively, what you can see what's happening here is you got this header on the left, which then feeds. So each of these 2 pins is a twisted pair, which is your sort of inverting and non-inverting inputs into these RS485. These are half duplex transceivers, so they can either be a receiver or they can be a transmitter, or in this particular case they call it driver. So these ones on the left here are all running in receiver mode, and then these are all running in driver mode. And the idea behind this is I could have the RS485 signals just basically flowing from the control box all the way through, with just each board having just the 4 receivers. The downside of that is while it's massive over-engineering for this particular case, the downside is that if there's any like signal integrity issues, the difference between the first run being, I think it's like 3.5 to I think it's like 4 meters, and then each run after that is about 75 centimeters after that. It's probably not required, but I would much rather just rebuffer the signal at every point. And that also means that if I ever want to change how this is laid out and perhaps have 2 boxes on one side of the gazebo and 2 on the other 3 meters away, because it's a 3x3 meter top gazebo. If I wanted them separately, then I'd be starting to push the signal integrity by the time you get the 3 meters up the leg. another meter across to get to the first junction box, and then like another 3 meters over there, and then another meter across, and then another 3 meters back, and it starts to add up quite a bit. And to be honest, these chips are cheap. Let me just find the specific part that I was looking at. Sorry, no, that's not on the right one. Here it is. So these are like 15 pence a piece. Sorry, I just realized you probably can't see that very well. Yeah, 15 pence. And there's a minimum quantity of 5 anyway, which obviously I'd be using way more than. But the yeah, 15 pence is like nothing. And to be honest, once I deploy that up there, there's absolutely no way I want to get up on a ladder and start diagnosing things and, you know, waiting for good weather so I can go and take a laptop and, you know, my picoscope and stop probing stuff. I really can't be bothered with that. I want it to just work and then work forever. So the additional cost of like having 8 of these chips instead of 4, and you know the additional solder joints that I get charged during assembly is nothing compared to, you know, even if I spent an hour like working on diagnosing this after it's been deployed, that hour of my time is worth more to me than the however many pounds I save, you know, a couple of pounds I save on cutting down the number of devices. Now, one of the things that I was discussing on Twitter was, and you might have noticed this if you were looking at how this is, you're looking at the numbers on here. You see here that these are numbered 1 through 8 on the left, and then they're numbered 8 through 1 on the right. And that's because when you rotate the RJ45 connector, the pinout's reversed. Now, that's not a problem for the individual pairs, because if you look here, you can see that when we rotate these, because these ones on the left, these chips on the left have been rotated 180 degrees. So you got the ground and VCC on the left, so pin 1's on the bottom right. That means that you get this sort of like AB on the left and then BA on the right. So that automatically flips the pins that way anyway. The downside is that, of course, now all of the pairs are reversed, so you've basically got pair 1, 2, 3, 4 coming in, and then it goes pair 4, 3, 2, 1 on the other side. And if you're connecting those with Cat5e connectors, none of those pairs are like flip round. They'll just be straight pairs. So that means that like this header in the middle is where the data connections will come out to go to the LED strips, and that's annoying because it means that basically on every other strip, on every other junction box, the connections would be backwards, so you'd have to keep track of like which ones you've used and which ones you're supposed to be using. That's annoying. Now, there's a couple of solutions for this. On a 2-layer board, because you need ground referencing for the signals, on a 2-layer board, there's not really any way you can do it, because if you move the signals to the other side, then they have to cross over each other as they route, which means that you get a ground reference discontinuity, which means that you're likely to get EMI, crosstalk, and a bunch of other issues. One of the solutions is effectively on one of the sides, like either on the input or the output. I would probably do it on the output. Before the signals go into the RJ45 connector, there'd be a pair of 8-pin headers, and what would happen is on the 8-pin headers would be there would actually just be like jumper wires that came out of that, which were then twisted together, and then I could manually like swap them with wires, which sounds kind of crap. Yes, 1, 2, 3, 4, 5, 6, 7, 8. Yes, that is correct. Which is effectively what we've got here anyway, because it's 1, 2, 3, 4, 5, 6, 7, 8, and then what we get here is 7, 8. 7, 8, 5, 6, 3, 4, 2, 1, 2. Sorry, I'm tired. Counting in like weird stepped reverse. It's like counting in the wrong Endianness. Flipping them round in pairs, so because they're twisted together, it's not a problem, because when they're as wires that have been twisted together, they reference each other because of the differential nature of the signaling in RS485. So that's fine. You can totally do that. It's pretty ugly, but it would work. You can't do that, unfortunately, on a PCB because the way that differential pairs work on a PCB is because they're not actually twisted around each other, which obviously you couldn't possibly do on a PCB. Unless you did some very weird things with like buried wires or something, that'd be horrendous. What you really actually have is two single-ended transmission lines referenced to a ground plane. Which means that as soon as you try to swap them over, they have to go through like a split ground plane at some point on a two-layer board, which just messes everything up. So you can't swap them that way. What I've now realised is I actually do want to do this on a four-layer board. Originally, a lot of my concerns were like it was like I didn't want to have to use a four-layer board if I didn't have to, but the cost difference isn't that high. Like it's fairly low, and one of the other benefits is that because I'm using JLC PCBs, PCB manufacturing and then assembly, is that they do a free option of an impedance controlled board, and that actually has a copper core in the center, which is actually quite nice to have. It does bring it brings the layers together closer as well. So the top and then so layers 1, 2, and 3, 4 then become closer together. There's less fiberglass between the two, and since the center two layers would be ground planes, that means that your outer signals are nicely referenced to the ground planes, nice and close. T says 1, 2, 3, 4, 5, 6, 7, 8. I'm not sure I follow there. T568B. I don't remember what that is. Let's find out. So now I'm confused. So is it not? Yeah, my understanding was that each pair going through the line, going through the wire, is matched up. So is it not? Are the pairs not in the same order when they come on the other side? They're not. I thought they were. So yeah, so it's 1, 2, 3, 4, 5, 6, 7, 8 on both ends. Yes? Now I'm confused. Oh wow, it's weird when you search for something like that and you click an image and you get an article and it's on LinkedIn. What? So yeah, I'm looking at the pinout now, and the pinout is, yeah, that's exactly what I expect. So you've got a T568B, so you've got pair 1 A and B, pair 2 A and B, pair 3 A and B, pair 4 A and B, and then on the other side you've got pair 1 A and B, pair 2 A and B, pair 3 A and B, going from 1 to 8. I am quite confused. Yeah, from what I'm looking at, they are pretty much just straight through. Like they're twisted round, but they go in the same order. So you've got like orange and white, orange, green and white, blue. What? Oh, this is very confusing because they keep changing it. There we go. Right. Oh, right. Yes, I see. That's very odd, because you get this like green and white, blue and white, green. Why are they flipped round? I mean, it doesn't matter because as long as the pairs are in order, like I know that it goes. So on both sides of it, it goes orange stripe, orange, green stripe, blue, blue stripe, green. Oh, it does matter because then they wouldn't be twisted around each other. So you're right, actually, on the 2568B. Ah, okay. I didn't know that. Interesting. That's really annoying. So that means I need to make some changes. Good to know. Thank you for that. Yeah, same for A. So apparently that's really weird that they've done it like that. Okay, so effectively the middle two change their pairing. I think I can work around that. I think, because so as long as I can loop one of the lines around the back, so effectively what would happen is for if I just look at this, so if I bring up, sorry, I just realized that you probably can't really tell what I'm talking about. So this, can I just this image, here we go. So on the right you can see here it goes orange stripe, orange, green stripe, blue, blue stripe, green, brown stripe, brown. So these two, this like 4 and 5, are a pair. These need to be in pairs because they're twisted together, and the twisting together is like one of the really critical parts for noise immunity. It basically gives you almost complete common mode noise immunity. So the problem is my signals need to go through one of my pairs of signals needs to go through 3 and 6, and then one of them through 4 and 5. That's not actually a problem, I don't think, because if we take a look here, so this is the part model for the RJ45 connector that I'm using. So if I actually do that left and then do this, and then bring that back out slightly. So I think what would happen is we would go, and it's coming in from the top, so it would be 1, 2, then it would be 3, and what would have to happen is instead of going directly to 4, I would have to get 2 signals through this gap between 2 and 4, route 1 down to 3, and then the other loop round down and then back up to 6, and then the next ones would go 4, 5, 7, 8. So it would have to come in and like loop back around. That's not the end of the world. There's also I could also do it where instead of looping all the way around and then back up to 6, I could actually have it come in and then go to 6 here, and then have it go 4 and then 5 around like that, and then 7 and 8. So that still works in terms of the routing. I can still do that. But thank you for that, Atty. That was a good catch, and I probably would have screwed everything up not realizing that. But yeah, I think I'm going to use a four-layer board for this, because that means I can just switch around the single-ended signals in the middle of the board. So effectively, this one at the top will go to the one at the bottom, and then these two will flip. So it'll be like top, bottom, and then the 2 middle flipping over. The reason that works with a 4-layer board is because when we move signals from the top layer to the bottom layer in order to route over each other, I'm not American. What you can do is you can put a ground wire right next to that wire, and you effectively reference the signal against that ground wire as it travels through the board, and then it's as it goes all the way through, you've got a ground plane on both sides of that copper core that you can then reference to, which is quite nice. It means you don't get signal integrity issues. So that's going to be quite nice, and I think that's going to work okay. The yeah, the header on here should be fine, although I don't think I'm going to just use a 4-pin header. These will actually be, it'll be a larger header because I want ground pins on here. And obviously these parts on the end need to be RJ45 connectors, which I need to model and everything. So the first thing I'm going to do is I'm just going to work on this schematic a bit. The other thing that I need to mention, obviously, is that this is like really simplified here. There's no protection on any of this. There's no biasing resistors. There's no termination. So obviously I need to include the termination as well. This is something that David Freisack helped me out with a whole ton, because when it comes to transmission line stuff, I'm really rusty, and I haven't looked at this very well. My brain just starts melting. I'm also quite tired today as well. So RS485 expects an impedance of 120 ohms. So normally, if you just assumed that the lines had no characteristic impedance, you would just stick a 120 ohm resistor over them, job done, you terminated it. Cat5 cable has a characteristic impedance of 100 ohms, which is pretty close. You could probably get away without terminating at all. However, I'm not going to do that. So instead, what you do is that 100 ohms is then split over the two lines. So every one of these, like 1, 2, 3, 4, etc. This then becomes A and B here, and then each line has a characteristic impedance of 50 ohms. So when you add them together, that's 100 ohms. So you need 20 additional ohms of impedance to get that 120 ohm match. And then this 100 nanofarad capacitor, when you run this through a low pass, so this is basically low pass filtering the common mode, any like common mode currents. If you work it out, it comes out, depending on whether you consider the characteristic impedance as part of the, it's basically making an RC network. If you consider it as part of it, it comes out at something like 160 kilohertz cutoff frequency. And if you don't, if you just consider this, it comes out at like 60 odd kilohertz or 50 odd kilohertz or something, which is good. That's fine for what we're doing. It's just a nice little bit of noise. It's basically like AC coupling. So then the additional thing that's going to be here is on the way in, there will be a TVS diode, a pair of TVS diodes to ground, and they're bidirectional. And the reason I want to do that is because basically because they're bidirectional, so they're 15 volt clamping, not clamping, 15 volt, they're 15 volt TVS diodes anyway, and they're bidirectional. And because these chips support plus minus 15 volts, what will happen is, if this goes outside, so this goes positive, let's say 17 volts, the TVS diode will start conducting to ground, and it'll conduct current to ground and clamp that back down to 15 volts. And if this goes negative 15 volts, well, the negative 15 volts away from ground, because it's a bidirectional TVS diode, it will also clamp and hold it at negative 15, and that will work for both of these. So it's basically just only a pair of TVS diodes on here. I will probably include a footprint for potentially adding a metal oxide varistor across the lines as well. I'm going to look into that, but I'm not going to populate that, partly because MOVs are all extended parts for on the JLC library, so I don't really want to pay the extended part fee for MOVs if I don't need them, and I can easily just order a handful and solder them myself. So they're like 1206 package passives, so 1206 package I could solder with my eyes shut. That's fine. It's not like 0603 where I've actually got to start paying attention, or 0402 where I've got to get the microscope out and really be careful. But yeah, so hopefully that'll be quite nice. So you can just see here that this is the characteristic impedance of line A, characteristic impedance of line B. These are not actual parts that would be in here, and then these are the termination resistors, and then you've got a capacitor in the middle. And of course we need also the decoupling on these chips. You might also be wondering, well, where's power coming from? That's separate. Basically, the 5 volt power that comes that drives the LEDs, that will also be driving this board. And there will be these are actually shielded shielded RJ45 connectors as well. So those will be shielded to ground. So there'll be a common ground rail there, plus the common ground rail that runs through the power. All of it will get tied together. So that way it's all like nicely just everything's grounded. Although I don't know whether actually, now I think about it, I don't know whether I want I don't know whether I want ground going through the shield and which is then connected to ground going through the wires, because then there's a loop. So you get potential like current loops. So what will probably end up happening is actually the shields on the RJ45 connectors will be connected to each other, but they won't be part of circuit ground. And that's just because, I don't want that. I don't want that loop coming back. And then it will just be ground terminated at the transmitter, like the driver side in the control box. So I think that's going to be something that I do as well. The other cool thing is that the RJ45 connectors that I got have LEDs on them, which I have yet to decide what they're going to do. They will probably just be used for power, and they won't flicker when all of the data's going, because I don't want additional complications. I just want it to, have some stuff going through. Yeah, I think that's fine. Just basically have one of the LEDs come on when there's power. That's fine by me. I have no real... I mean, it would be cool if they flickered when data went through, but, there's a whole thing with, like, if I put a transistor on it to drive those LEDs, then you've got gate capacitance, which is probably not a lot, but still, like, I don't know. Although, yeah, now I think about it, I don't think that would matter at all. But, I just can't be bothered, to be honest. And with the data rate, you probably wouldn't be able to tell, really, what was going on. I don't think it would really show up. It would just look like a dim LED. Because it's like 800 kilobaud as well, which is the rate of the SK6812s. So the first thing I'm going to do is I'm going to make a part. So I need to go into my parts library and schematic library, and I'm going to use I'm going to cheat, I think, and use the symbol wizard. It's not really cheating, because, like, yeah. Although, actually, yeah, no, I don't like that. No. I'm going to make a new part manually. So it's add component, and I'm going to call it, I need the name of the part, which is whatever the heck this thing was called. I believe it is this one. Yeah, it's the YG one. I mean, I could use either the GY or the YG. It literally does not matter, so I will just go with this one. So that's the part. One thing, I was about to say, one thing that I really wish this would stop doing is starting my pins at, like, really weird numbers. It's not a magnetic jack. Thank you for that one, but yeah, no, it's shielded but no magnetics. What was funny is I almost forgot that, and then I remembered the thing about the Raspberry Pi when they shipped them all without magnetics, and they just didn't work. And then I was like, oh, I need to do that. I need to make it not magnetics, because then, yeah, that would not work at all. The first thing I'm going to do is, where is it? Yeah, I'm just going to move this off screen a bit. Oh, actually, you know what? You can say this one as well, and although we do not need this to be this wide. What? You don't need that to be that wide. Nor this tall. Super weird when you, like, zoom in on this stuff and it crushes all your... I'll turn that off. Oh, wow, no, that's ugly. No, I'm pinning that back down. Okay, so, yeah, I don't want pin 44 because that's just silly. So let's go with pin 1 and also call that 1. And I think I'm going to lay it out like it is here with this, like... I'm not going to do steps, but I'm going to lay it out in this orientation. It just helps me mentally understand where everything's sitting. So yeah, so we got 1, 2, 3, 4, and then another 4. So then that's 2, 3. I'm pretty sure there's like a macro or something to automatically increment these, but I can't remember what it is. And I cannot be bothered to look it up. So then we also have these like pins 9, 10, 11 and 12. And I'm going to do those, oh no, don't want to do that. And I'm going to do these like off to the side in the same way that they are here. So this would be pin 10 and that would be 9 and that would be 12 and 11. So that is 12, 12. And what I will do is change the names of these pins because it's then easier to remember what they do. Because the designator is just so the designator is basically like a pin number. It's what you would refer to on here, but the name you can just pick anything arbitrary, and it's just what gets shown here. Yeah, you can edit it through that way as well, through the panel. So that is the, oh, my brain isn't working, anode for the first LED, which I believe is the, it's not clear whether this one's the yellow or the green, but I think it's the yellow, because I think it's YG, so it's the first and then the second. So this would be LED Y anode, and this would be LED Y cathode. In fact, I might shorten these because that's going to be like big and chunky on the thing, and I don't really like that. So let's go with I don't know, LY A and LYK, like, and subscribe. So then this would be LED green anode, and then LED green cathode. And I can write descriptions for this. LED green anode, and then do the same here. And as much as I initially hated people using A and K for anode and cathode, I actually now realise why everybody does it, and it's because the line and the two parts of the triangle looks like a K backwards. So it's easier to remember which one's which. And then, of course, the anode looks like an A. And I'm a dumbass, and it took me ages to realise that that's why people did that. And I also just realised, I think I put green on these, didn't I? Yes, I did, because they're not green, they're yellow. Because I'm silly. I also got 10 minutes of sleep last night, so I am running on fumes. It will not be a long stream tonight because of that aforementioned lack of sleep. Excuse me. Right. So then I'm going to put a box because all good parts come in a box. 1, 2, 3, 4, 5, 6, 7, 8. I kind of like them like that. And then I hate how like sending things to the back is kind of annoying. Yeah. I wish there was just like a there probably is a hotkey or something. I'm just and I call my connectors J. I apologize that you can't see much in the properties box. I have no way of making that any bigger. And I'm going to take the description of this, which is doop. Of course it's under. It's good if I didn't click off the damn page, isn't it? Right, there we go. That's what happens when you like stream at you know, 11:30 on a Saturday. Everything's down for maintenance. Okay, remind me not to click anything that takes me off this page because I'll lose it. Not that it really matters now because I got the data sheet up, but yeah. Okay, so what I am gonna do is yeah, I'm gonna, if I can offset these pieces of text slightly, I think it's this one, and then oh, it's that one, isn't it? Yeah, here we go. So oh, you can't shift it vertically like left and right. Yeah, no, you can't easily do that. What I was gonna do is just move the text over and then draw in a little LED. I suppose I could just, yeah, I suppose I could just change these to actually like proper text and then just hide the text and then draw the LEDs in. So yeah, LED G cathode, LED G anode, LED Y cathode, and LED Y anode, and then I'm just gonna doop and hide. So then I'm gonna draw a little doop, and that is, yeah, going that way. Hey, look, it's a short circuit. So then I'm gonna put my grid in 50mm mode and then, do I care that it's off center? No. Yes. God damn it. Oh, no. That's not what I meant to do. And then I'm going to put my grid in 10mm mode and move this across so it's nice and centered. And then I will take that and I'll put it here. And then I can put in some text, which, oops. Put in some text. What do they call it in here? Text string, just to be confusing. So that will be LED yellow. I don't know why that's in blue. Although actually I kind of like it in blue because then I can, yeah, I really should have made all of these. I can make these blue as well, which would be nice. Yeah, I like that. Although this is like some darker blue. Where's that reference from? Interesting. Oh well, whatever. I am not at the point of caring about like font color. Like, I get annoyed about things not being centered and stuff, but like, yeah, no, I really can't be bothered with like, is the font the exact same color as the lines? Just... no, I don't care. And then I'm going to draw like a little, where are we? Yeah, something that just looks like that. And then look, it's a little RJ45 socket. See? Electronics, it's all about drawing pretty pictures. And then they can move over. Oh, what? Oh, yeah, that doesn't even help at all. Yeah, that'll do. That was like a Ethernet socket, right? Yeah, something like that. Whatever. It's got little LEDs on it, look. There we go. That looks like a Ethernet socket to me. It also looks like a face, like a little robot face. I like it. It's cute. You know what I really should have done is use the part importer and import it off of Farnell, which wouldn't have worked because Farnell's down. And I probably would have spent ages going, oh, why isn't this working? So, cool. So, now that's done. Let's maximize this again. Now I can delete the header. And then I can go into my components list. And let's load up my parts library. And then somewhere in here, here it is, which is now much bigger, but nice and shiny. Now, again, I need to remember which my pins are that I need to swap. So that's 3 and 6. And 4 and 5, so it needs to go something like so 1, 2 connect, then this can go to 3, and then this needs to go to 6. No, I'm not going to do it like that because that won't fit. I'm going to do like 3 and 6, and then god, see, I hate this. I also hate that you can't like just easily. Oh, you can. Huh. Did not know that you could do that. And then... No! The polarity doesn't matter, because as long as it's equal on all of them, it doesn't matter. Like as long as it's the same on both sides, it doesn't matter whether the positive is on the solid or hatched wire, as long as it's consistent. So I don't need to worry about that. I believe I can use... Oh, you can't use space to... I always thought you could. Oh, that's really annoying. Why can't... Yeah, but that doesn't matter because they're twisted together. So as long as they're, yeah, like I don't think it really matters. And also, it's just more faff to fix in the board design. Like it's more of a pain. This is literally not. I thought I found a cool feature there, and it turns out that it's actually just useless. Right, so it should be. Is it shift space? Oh, you legend! That's very useful. Good. So, oops, I didn't mean to do that. Let's move that one back. Did not know that you could use shift space for that. See, the one that I was told was space for like flipping the. Oh, and backspace will go back. Cool. See. I'm like fairly new to using LTM. I used to use Ultiboard and Multisim by NI, but I feel like those are so out of date now. Like using those now, it feels like using early 2000s software. And the simulator library, like the parts library and the simulator for Multisim, hasn't been updated since I used it. Like since the first version I ever used, which was when I was a teenager. So kind of feel like it's not worth it for that cost. Yeah, it's like they've got a really nice spice library if all of the components that you're using are TTL or like early CMOS. It's just like it's really, really old. And then like Ultiboard, some of the routing features are all really weird, and you end up getting a lot of like really odd looking boards. As soon as I switched to Altium and made my first like board design on it, it went from looking like some garbage thing that somebody sort of hacked together in their spare time, totally not what I do, to like legit looking reasonable board. Now I just realized that I have put all of these in. So what I'm going to do is I'm going to put like net flags in this. So I'm just going to delete this for now because actually no, I'll leave that there as a reference. So obviously I need to be able to put my termination resistors and all of my protection stuff in here. For neatness, I don't want to draw that directly in here. I'm going to put in... I tend to use off-sheet connectors. I know ports are supposed to be what you use, but I don't like the look of ports. They're weird. I just kind of like how these look more. So this would be input. Oops, in A. No, in 1A and in 1B, because that's then input 1A and B, which tallies up with the A and B on each of the chips, which then I can add these. No, I don't look at that. I look at that to here, and to be honest, I'm just going to move that over. Have them all nicely in line, even though they're kind of close. So that becomes in 2B. Oops. And then this is 3A. And this is 4. Oops. It's not the button I meant to press. So that then gives us the 4 input signals. And then of course I need to do the same on this output as well. So let's take this out. And you can see here now, you can maybe see here now, if I zoom in a bunch. I don't know how well it's... you can see that this is 8 through 1 rather than 1 through 8, because obviously it's rotated around. So I will put this over here. Can I do the same on that side? Oh, I just kind of arbitrarily placed that one, didn't I? Yeah, whatever. For consistency, I will put this one... No, I won't. I'll just put it wherever I like. Like, did I really put it like here? Yeah. Yes, I did look for tab up and tab down connectors. Unfortunately, there's none where the pins are reversed. One of the reasons is that these are cheap, like through-hole multi-comp. I think they're no, they weren't multi-comp, were they? Something else. I don't remember who makes them. Who is it? Is it multi-comp? No, Stewart connector. But yeah, they're cheap. They're like £1. Yeah, in order to get the reversed ones, I had to go like quite a bit further down, and yeah, they started getting kind of pricey, and I don't want that many of them. The other thing is that a bunch of them are they got surface mount pins on the for the data lines, and like you could get ones with swappable ones for that, but I would much rather have through hole, partly because I only want to get 5 of these made, and I only need 4, and I don't want to, and that means I only have 1 to solder at home that I could mess up, and I'd rather have the through hole for that. And secondly, for mechanical reasons, through hole's going to have more mechanical rigidity on the data lines, but mostly just because I suck at soldering. So these actually don't need to cross over on this side, as in they will need to do the like data line flipperoo, but they don't need to crisscross over the pairs on this side, because the crisscrossing over is going to happen in the middle here, and I'm going to like rejig that shortly. So this will, and you'll notice that if you look up here, this is A, B, and this is B, A. So these are automatically already flipped. So this would be fine, and this is also fine. I just need to remember and then reverse how this happens. So it is well, I guess it is just the same, isn't it? It would just be this bottom one comes up to 6, and then wait, no, would it? Yeah, so this bottom one goes to 3, because just like here, this one goes to 3. And then 6 comes down, I believe. And then goes to here. And then the other 2 go across. Yeah, that's correct. Yes? Yeah, that's correct. Yeah. Oops. Of course that happens. Yeah. Because if we then look, this is the same thing happening here. So here, 6 goes to... Oh, wait, no. This does need to be the other way around, doesn't it? 6 and 3 go up to here, which means that these 2 need to come down to... So these need to go to 6 and 3. What? My brain stopped working. So this one... So 3 and 6 go to here. So A on here is on number 3. So A on here should be to number 3. So yeah, I definitely messed this up. So let's get this right again. Yes. Oh no, I did get it right. I got it right. I know why. So what's happening is, what I haven't done is flip these around. These will actually flip around. So this will actually be 1, 2, 3, 4. In fact, I'm going to put some text in just to indicate this, because they're going to flip around. Ignore the wiring in the middle, because I'm going to change it. But I'm going to put this in and make it bold and nice and visible. This is what was confusing me, I think. So this is 1. Let's move that down. So this is 2. This is 3, and this is 4. But what's going to happen is these are actually going to flip round, like this. So you'll see that port 1 comes up here. So pin 1 A for 1, and then down the bottom, pin 1A goes to 1, pin 1B goes to 2. So that's correct. And then on the other side, we've got channel 4, which is 7 and 8 to A and B. Channel 4, 7 and 8 to A and B. So that's correct. So then we've got 3 and 6 going to channel 2, A and B. So channel 2A goes to 3 and 6. And then on this last one, we've got channel 3, which is 4 and 5 going to A and B, which means that 4 goes to A and 5 goes to B. So yeah, that's correct. It's this bit in the middle that was throwing me off. So that is actually correct. Although apparently I somehow managed to make that really long, because I can't look properly, but that's fine, because who cares? So the next thing is that all of that is disappearing, because we're going to do the flipperoo. So I'll just move this like way over. That looks about right. I probably made that like way too much. So normally these are like RO to DI directly, but what I'm going to do is I'm going to have this. Oh, it's a shame you can't. Oh yeah, you can. Awesome. Hey. So let's go with like that, and then oops. So let's and that's like 1, 2, 3, 4, whatever, and then that will go like that, and then let's do the same thing here, which I think I'm in line. Looks about right, whatever. So those two have then flips over. Yeah, that looks like really jank. Yeah, I thought that was wrong. There we go. That looks... There we go. That looks great. Right. And then do the same here. And then this will go here. It's a circuit. It sort of looks correct. And then how do you... I can't remember how you meant to do that, but that's fine. Hate when that happens. Hate when that happens. What the hell? Come on. What was that? Thank you. Right, there we go. And now I can... Oh god, no. Okay, I'm gonna just... That didn't go well. So yeah, so now you can see that 1 goes to 1, 4 goes to 4, and then 3 and 2. And then these will then tap off and become... get connected, go to a connector. So I'm gonna put some more... So let's call that just channel 1, 2, 3, channel 4. So these are then... Wait, no, that's not correct. That's channel 1. So I've done this after the flip. 2. And that's channel 3. And that's channel 4. So then the next thing I want to do is apply this kind of thing again, but these are for the outputs. Did I do it like that? I did it like that, didn't I? No, they actually are supposed to be that close. That seems weird. Did I just do these wrong on this side? Probably. Who cares? Yeah, that's ugly, but whatever. It works. So this is then out one. In fact, what I'm going to do is select all of that and then go edit, replace text, and change out to in to out in selected objects and case sensitive, and then okay. So there we go. In fact, I should have just selected all 4 of them and then done it that way. So now I don't. Then I didn't have to edit these, but whatever. Who cares? Right. And I'll sort the LEDs out later. I might just have both of them connect to power and ground. Who knows? I think I actually missed a pin off of these parts because what I want to expose on those is the shielding. Now, on the data sheet, it doesn't specifically say which of these are yeah. I really hate how label nets how net labels look in Altium, and I much prefer, and also ports are kind of weird. I much prefer to use the off-sheet connectors because often what I'll then do is later I'll decide that I want to have things like decoupling just on a different sheet, and it's just easier that way. I know it's kind of a bit of like a weird abuse of the feature, but they work the same, so so I believe looking at the image of these, the two large holes, it's not that one, it's this one. It looks like the two large holes, I know these are just for reference, but I think the two large holes are just plastic, whereas the pins just behind, I think, are actually connected to the case. So I believe that these two pins here are actually connected to the shielding ground, because they're connected then to the because they're shielded connectors. The actual metal of the outside of them is connected to the shield. So what I want to do really is modify these footprints, modify these parts to actually include that. I forgot to do that before. Luckily I can just do that, and then I'll just save this first, and then so if I go in here I can add a couple of additional pins. Now, yeah, I'm going to put them on the outside here. Yeah, exactly. Yeah, the plastic would go into a non-plated, whereas the metal mounting pins would be metal. Would be a plated hole. Yeah, so I'm just going to copy that, and I'll put that there and like there. In fact, no, I don't want to do that. I'll base it on this one, because then I don't have to be quite so lazy. Or rather, I can be more lazy. So the designator here, I'm going to put like... I don't want to use CH because that sounds like channel. I'm going to call it SH1. And then, yeah, SH2. The other thing is that, yeah, I suppose that's fine. Cool. And what I can actually do is add descriptions to these, just so that I don't forget later. So this is shielding / chassis metal pin, and I'll put the same on this, just so I can remember what they do. Cool. So then what I can do is just take that one, and then right click, part actions, and update selected from libraries, and I can just hit finish, validate, execute, close. There we go. So that's nice. Although I'm not sure why it's moved my moved all my texts around weird locations, but that's fine. I can move them back. It's probably because they were already placed on the board, and it's just decided board. I keep saying board for some reason. They were placed on the sheet, so they've just been shifted about. Yeah, exactly. I think the text was already there, and it's just and moved everything around. Cool. Yes, the box has grown. So what I'm going to do is I'm going to add a net label for. I'm going to call this one like, I don't know. I kind of like the Earth symbol for this. I kind of feel like that's apt, even though it's not really Earth, but like whatever. Although it may well be by the time I... What's going on here? Like, what's with this like weird... Why is it... Did I not put these... Oh, I didn't put these on a... These aren't on a grid. Yeah, these are off the grid because I put this in 50mm grid mode. So that explains why that looks all weird. So if I change my grid and then Control-Shift-D, and then that's align those back onto the grid. So there we go. Yeah, that's more like it. That makes a lot more sense. I was slightly confused as to why that looked a little odd. It's not actually even. So there we go. That's better. So now let's update these from the libraries. Finish. Validate, execute. Job done. There we go. That's nice. So there we go. So these would be nice little signal ground. There is actually a signal ground one, but I don't like the I'm not a big fan of the way that symbol looks, and to be honest, it doesn't really matter for this purpose. Because the other one uses the triangle ground, and I always associate that with like digital logic rather than like normally I would probably use that instead of the normal ground ones on here, but whatever. I feel like for shielding this is kind of, it just fits nicely. Cool. So yeah, in this particular case, what would happen is that the this SH1, SH2 on both sides of these will be connected together, but they won't be connected to the ground on the board. That will be via a separate inputs. So the next thing I want to add is I'm going to add a pin header, and what I want to do is I think I'll go for an 8-pin. There's a method in the madness here. I know I've got so I know that normally for 4 signals you can get away with basically having a ground per 2, because you effectively sandwich, you go like ground, signal, signal, ground, signal, signal, ground, because then you've still got a ground reference next to every, because of the equal spacing, the ground references are on every signal effectively. But the in this particular case, I think I'm going to go signal, ground, signal, ground, signal, ground. I need a 8-pin header, sorry. Because in practice, what's actually going to happen is for each of these... I could do ground, signal, signal, ground, signal, signal, ground, because... So my thought was that because each of these in each junction box we actually only tap off one at a time. The only reason I'm putting making all of them available is so that I don't have to have a different board for each box, which financially doesn't make any sense. I could just go ground, signal, signal, ground, signal, signal. Oh, that literally saves me a pin, so I don't care, because it's ground, signal, signal, ground, signal, signal, ground. Yeah, which would then be 1 pin. So instead, I'm just going to go ground, signal, ground, signal, ground. So then the idea is that when that goes off to the, there'll be a wire that comes out of this box and then goes down to the LED strip. And I want a ground line in the signal wire. That's on purpose. And in fact, I can't remember exactly what wiring I was going to use. So I could do that. Yeah, I could just tap off one and then shift them all up by one. But one of the reasons I don't want to do that is because I want to be able to reuse this design elsewhere in situations where exactly flexibility wins. So I can reuse this design elsewhere where potentially I might want multiple nodes having the same data come off. So yeah, potentially I might reuse this at a later point. And to be honest, I feel like the layout is fairly simple, and the part count is like the part count difference is basically nothing. So I might as well just do it this way. So yeah, we get 1, 2, 1, 2, 3, and 4. Really? There we go. Do. And then I'm going to rotate those back to 0, I believe. Oh no, it's going to be 180. There we go. So then I'll probably have these the other way around, just because I like them reading 1, 2, 3, 4. It doesn't actually matter that these are drawn the other way around, because obviously on the non-flipped side it will be that way. And then yeah, so then these will just connect in like so. and then the rest will go to ground. Now, again, with the idea of having these as a ground and signal pair coming out of the box and going into the LED strip. Technically speaking, what I should really do is have the two wires come out and then the ground actually join the power ground that's then going to go out to the device, rather than having two separate ground lines, because again you get the potential for loops and stuff. I don't think that's really a problem in this particular case, particularly because anyway what's really going to happen is there's actually two power wires coming out of each node. One goes to the near side, and then the other one actually runs all the way over another 3 meters back over to the other side of the gazebo and comes down and powers the strip from the other end, because that way it's powered from both ends and you don't have to worry about voltage drop across. It's not, technically speaking, the most ideal way of doing things from like a signal integrity perspective, but for 5-volt power like that, it doesn't matter at all. Like, I can't see a way that would ever matter. So yeah, it's all about just getting the right amount of current down the line to handle that one. So the next thing I'm going to do is there's actually a part that I need to import. And one thing you might have noticed is, well, maybe you didn't notice. It's probably actually wouldn't blame you if you didn't notice, because it would be quite hard to spot. Oh, it appears like I've lost the page, but you might notice that there's a bunch of additional data in here in this pop-up for the part, which is not normally here, and that's because I wrote a Tampa Monkey script which pulls in JLC PCB parametric part data into the thing. However, if you saw that, you may not have seen, but I also wrote one that pulls in JLC PCB stock numbers for parts on LCSC as well, so you can do it both directions now. And I actually fixed a bug in that this morning. Yes, the other way around. I actually fixed a bug in that this morning. Was it last night? I think it was last night. Where it actually turns out that JLC PCB's part API will actually give you results for parts that don't exist in their library, and the only way you can tell the difference is that the part name is null, but they will give you stock data and pricing for things. And the way I caught it was there was an ME2 CO gas sensor. It was a carbon monoxide gas sensor, which is actually like a I forget what it's called, the type of mounting. It's not through hole, it's the ones where you've basically got like a peg with a round metal sort of lug on the end of it. And that popped up on LCSC, and then it showed up as in stock on JLC, and I was like, that is not in stock, because they don't do through hole, let alone whatever the heck that is. So I managed to catch that and figure out what that was about, and fix that one. So that now shows up as not available when that is. What I should really do is put in a thing that says this is a ghost part. But yeah, I guess that would be more confusing than anything else. Ghost part. But yeah, so this is actually really useful to me when I'm doing parametric search on here. There's also let's see if I can find it. Here it is. Honza, I'm going to pronounce this really horribly. Honza Mrazek? I don't know how to pronounce the accent on that A. I apologise, but made this cool thing, which is a fully parametric search thing for JLC PCB. So you can, just search all of this stuff fully parametrically. It uses client-side storage to pull all the stuff from the APIs. So you basically like hit this and it updates all of the stock data and all the component information, and then that stores locally, and then you can just do full parametric parametric checking, which is really cool. I will put it in chat. I've been using this quite a lot because it's very shiny, but it's also nice to, when you're in the when you're in the just on their website or on LCRC to also have this data. So yeah, fun. So yeah, one of the things I was looking at was TVS diodes, which I believe I clicked this, and then it's an extended part that I was using, and I believe it is, what was it? It's on here somewhere. It's not that one. It's this one, SMBJ 5.0. No, that's the 5 volt standoff one. Did I lose the part that I was looking at? It's not this one either. I must have accidentally closed it. So there was a bidirectional. It was a bidirectional TVS diode that was, I believe, 15 volts. So if I put in 15, don't know whether this was a. Don't think it was. I think it was this one, SMBJ15CA. I believe it was this one. Because if you go down to here, SMBJ15A, yeah, this is the one. So it's got, it is bidirectional, I believe. Yes, because the B is bidirectional. Yeah, so A, I believe, is the single direction. Yes, as in positive and negative. So it will clamp either 15 volts over the TVS or negative 15 volts over the TVS. It'll clamp to whichever of those. So the idea is that for each of these lines, it'll go 15 volt TVS, ground, 15 volt TVS, and that way when the voltage between ground and that line is exceeding 15 volts or minus 15 volts, so 15 volts in magnitude in either way, it'll clamp, which is useful in this particular case. So where were we? So yeah, so we got this part here, which was no, wait. Oh, so this was the right one. I just didn't realise that. Yeah, it starts off with 5 just to be confusing, because it's like, oh yeah, look, here's a 5 volt, but it's not 5 volts because it's here, and I'm an idiot. So yeah, so the first thing I'm going to do here is I'm going to take this C11 blah blah blah, and I'm going to I'm just going to hit save all for now, and then I'm going to go into my. Oh, give it a minute. You would think with a machine this ridiculous, Altium would not freeze up on saving things, which, if you're not familiar, when I say ridiculous, I do mean quite ridiculous. You would think that Altium wouldn't freeze up, but hey ho. Right. What was I doing? Panels, and then yeah, manufacturer part search. The files are stored mostly. No, they're not on a network share. The libraries are on an NVMe array, so they should be incredibly quick. And the project files are just stored on a hard disk, and the hard disk is, reasonable. So I'm going to search for this, find a part. Couldn't find the part. Of course, it couldn't find the part. Why are you like this? See, I always find that it struggles sometimes with JLC parts. Like, I can put in the part number, see if it comes up with that. It seems to struggle with coming up with parts that only exist on JLC. See, this is the other interesting thing is these part names. If you check these part names out, a lot of the time, these like SMB J15CA, they're identical to ones made by like Western brands, but they're just some like random other Chinese brand, which is fine. It's the same part, mostly. But you've got this like SMB J15CA, and that's a little fuse part, and then there's another one that's very similar, that's an ST micro one, and then all of these ones, Taiwan Semiconductor. I'm guessing these are just like standardized ones, but it just gets very confusing when I'm trying to find the correct one. So this is supposed to be by What is that name? MDD bracket microdiode electronics bracket. That's not really a name, is it? And that's the other confusing thing, is when you click on a lot of these, you often get different, the datasheet comes up with a different company name. But yes, so this is supposed to be MDD. Amusingly, this one's made by MCC. So is that the knockoff MDD? Or the knockoff, is MDD the knockoff MCC? I do not know. Where are we? I apologise that you probably can't see a whole lot going on in this on the right here. So I think... Here we go. So there are 10 SPNs here. I bet... Oh, there we go. We've got one in LCSC. So I think it doesn't actually have the proper part. I think it's got like a variant of the part that it can find for some reason. Because I tried putting this in and it didn't come up. Oh, there is another SMBJ, and this is the same price, and it's a different part code. So if I try searching this part code instead, this is another thing that like confuses me sometimes. And then that's not the part either. I know, it's cool. So yeah, this is kind of annoying. So I might actually just search. You see, this is where it gets useful that I've got this plugin where I can just go TVS, find a TVS diode, and I want bidirectional, and I want the typical standoff voltage to be 15 volts. I don't like 15 volts max. 15 volts is fine. So then I'm going to sort by price. Yeah, no, they're not going to be in the Ultium Vault. It's the so the part import thing actually searches through all of the vendors. It actually finds all the vendors directly through their APIs. It's not in the vault, which is quite useful. So yeah, we've got this Bright King Electrics. I would have thought that's confusing. SMA is the same, and it's also bidirectional 15 volts. Wow. All right, if you say so. I'm not going to complain at that, and that is in stock on JLC. So let's see if we could find this one. That looks acceptable. So we can find it here. And yeah, again, this is really annoying. LCSC, like the, so I hit the cog button on here. Go to part providers preferences. Yes, the only reason I'm actually trying to import from LCSC is that it takes all the parametric data and puts it in for you, so I don't have to manually enter it, which I should have done for my Ethernet connector, and I'll probably do that off stream and just re-import and then move the symbol over. So it won't give me the symbol, that's not the problem. It's just I like getting the parametric data out, but at the moment this is getting silly. Yeah, like, I've got LCSC enabled. It's just a bit weird. Like sometimes it just won't find parts that are on LCSC, even though they're on there. And I've put in the part number, and it just won't find it. So sod it. I guess I'm not getting that out of it. So I actually already have somewhere in here. I believe I have a TVS diode. Or do I not? So I've got stuff like this already in here. All I was going to do is basically just steal the the footprint. Not the. I keep saying footprint symbol. Yeah, I don't actually think I have a. Really? No, it's not an 8226. Ah, that's definitely not what I'm looking for. I was sure I had a... I guess not. Okay. Well, never mind. I'm sure I can do something about it. So I'll steal this footprint anyway. I keep saying footprint. What is wrong with me? I will steal that, and then I'll make a new part. And the part is called some random ass TVS. So I don't know which one I'm going to use now, because I guess it doesn't really matter. Extended parts. And it was, I think I just put like 15 and then went to extended parts in TVS. Yeah, I guess whatever's cheaper, if this is bi-directional as well. Let's find out if this is also bi-directional. I think this is unidirectional. Right? Because... oh, it doesn't say bi-directional. Yeah. Okay, that's interesting. Oh, okay, so it's CA on the end that makes them bi-directional. Weird. So 15. So these are bi-directional. So this is the SMA. Yeah. So this is the reverse standoff voltage of 15. Breakdown between 16.7 and 18.5, which, to be honest, is very similar to what was up here, I think. In fact, it's identical. So what's the difference between the two of these? Hey, I think these are just exactly the same, are they not? No, they're not the same. It's this peak current is much higher on the SMB. And for the, you know, fraction of a penny difference per unit, I might as well go for that. So I will call it... oh, and you know what I've done? I copy-pasted it. And, yeah. That wasn't very bright. Overwrote what I'd already copied. But anyway, I can go back into the LED wherever that was. There it is. And then just take this. And then, there we go. Steal it. Because if I remember correctly... I don't remember the symbol for TVS diodes. It always breaks my head. It's two... the bidirectional ones, it's like two Schottky diodes back to back, right? Or Zeners, rather, not Schottkys. Yeah, so it's basically just that. Yeah. Oh, okay. Yes, of course they're yeah, facing. Yes. Okay. I'm tired. So let's move this over. I'm going to put that one in 50mm grid. Oh, right, yeah. No, that's not what I wanted to do. Just want to move. Can you not? There we go. Really? So there we go. And then this just needs like the little wiggles on it. Yeah, and then I need to put that in 10mm grid. Yeah, I kind of like them about that big. Yeah, seems about right. Yeah, yeah, cool. And then I will make them the same colour as the rest, because that's critical. Part won't work unless I do that. And I know these are set as A and K, so instead I'm just going to set these as 1 and 2, because obviously it's not the same part. And it literally doesn't matter which way around these go. I think I'm also... I don't quite like how long these are. think I actually prefer them short. Just because it's a little easier to draw when I move them over this way. And it was called C something or other, wasn't it? No, it wasn't. It was called SMB J15A. The other thing I forgot to do is put any kind of... so that's TVS question mark, and then description. I'm going to steal from part description, which is what? And then I will put in the various parameters, and then I can edit those into the... I can properly edit those in later. So this is... Oh, that's for the SMA, sorry. It should be for this one. It's the same description, but... so 15 volt. I think I can actually just select all of this. So the first one is standoff. And it's breakdown, I believe. Yeah, breakdown voltage, and then maximum clamping and current are the only ones I really care about. Cool. Sorry, I apologise that you can't really see what I was typing there, but it's just to keep that nicely in my parts list. Lovely. Good to know. So what I'm basically going to do is I believe I don't actually have I'm not going to bother putting resistor parts in and importing them and everything, because I can't be bothered. I'll do that later. Instead, I'm just going to use the miscellaneous devices. There's a part in here, Res3, which has a chip resistor footprint, 0603. In fact, it shouldn't be an 0603, because when I change this, some of these specifically have to be some of these resistors specifically actually have to be higher power, because the terminating resistors can actually sink a bit of current through them. They need to sink a bit of current through them. So when I looked at this before, it was just shy of a quarter watt, which is slightly annoying because the 10 ohm part that I want to use is the highest power rating I could get was a quarter watt. So I'm gonna have to use two in parallel, two 20 ohm ones in parallel, just because I don't want that little overhead. I don't want to go from the max expected power that I'll need to sink through it is what's the quarter watt rating for? The quarter watt rating is so where is that design reference that I was looking at before? Is it in here? It is not in... Wait, is it in here? It's not this one, I believe. So if you look at a lot of RS485 termination, you'll see that a lot of them are actually, and in fact in the official, where is it? I think I have another page open somewhere that has this particular bunch of, here we go, here it is. So in the official standard, which you may not be able to see very well here, but I'll zoom in slightly. You can see here that this is, it's actually expected to be a 1 watt resistor terminator. Yeah, exactly, 208 milliamps. I think the way I calculated it was V squared over R. which works out at like 25 over. It's 25 over 120, which is 208 milliwatts. Yeah, which is what you got. Yeah, so well, milliwatts, not milliamps, but yes. Yeah, so it sort of yeah, it does require a fair bit of power. So yeah, it's basically instead of using 10 ohm, I'm going to use two 20 ohm resistors at. I believe I can add this in here. I'm going to remake these anyway because I'll need to be getting specific parts. But I'm going to add a parameter here, isn't it? Yes. And then I'll put 1/4 watt in here, and I'll put power dissipation. So there we go. So we've got this 1/4 watt, and I'll turn off the comment as well because we don't need the. Excuse me. I will turn off the comment. There we go. Oh, that's fine. Anyway, yes. So a pair of those on each side. So the termination will look like this. Now, the one thing I can't remember, in fact, I think it's in this. It is in this, but that's on there. So, oh yeah, no, it wasn't in this, was it? No. So the whole thing about this capacitor in there, I can't remember whether that capacitor is supposed to go to board ground or whether it's supposed to go to the shielded ground. I believe it's supposed to go to board ground because the idea is not that you send you want to have this shunting to your local board ground, I think, but I might need to check that. And also, look at that. Sneaky. See, that's how they get you, or something. So that's on the. So each of these is on the termination input side, and also there would be a pair of TVS diodes. So that one and another. So that would then come here and there, and this goes across like this, and this goes across like this, and then this would be let's call this, let's use 1 A and B here. So this is effectively what the inputs, the input termination looks like. So you've got this, yeah, over the input 1A, 1B, and this will be repeated for 2, 3, and 4. You've got these termination resistors. You've got the capacitor for forming RC filter to couple high frequency common mode currents to ground. And then you've got these TVS diodes to clamp everything within the 15 volt plus minus 15 volt range on both rails of that. So the first thing I'm going to do is just move this out of the way. I'm going to move it up here because that seems reasonable. This I no longer need as a reference. So these are on the inputs, and I obviously need 4 of these. Yeah, no, I'm going to move it down to there. So I'll need that again. What on earth? What? That was very odd. Copied it without any of the wires. How strange. There we go. Let's do that again. So this would be 2, 2, 3, 3, 4, and 4. Yes, they're 20 ohms each because you've got 50 ohms characteristic impedance in each line. which is 100 ohms impedance, and you need 120 for RS485. So when you parallel these two together, you get 10 and 10. So that's 50, 50, 10, 10, and that gets you 120. Maths. Cool. So, yes, it is. Because the characteristic impedance of the line is already 100 ohms, you only need the 20 ohms of termination resistance already. Yes, so normally you would have 120 over it, but that's because you effectively consider the lines to have no characteristic impedance on the normal RS485 cabling. Instead, in order to get, because the Ethernet cabling already has 100 ohm characteristic impedance, you're basically just adding in an additional 20 ohms to get that 120 ohm total. There's this was something that we had a very long conversation on Twitter about today, and I wasn't entirely sure, but it does in fact appear to be correct. I don't know whether I've got it up here somewhere. So here's the thing describing the split termination, but that's not what I was looking for. There's a guideline somewhere that I read that talks about it's if I remember correctly, so there's some guidelines somewhere about running RS485 over Cat5, and what they came up with was that it was supposed to be 20 ohms at the end to match it up. I believe there was an electronic stack exchange answer. Here we go. No, this is not what I'm looking at. Can't remember where I was looking, but there was basically a thing that was saying it should be 20 ohms. Yeah, it's some like I don't fully get it either, but it's something to do with the fact that it's something to do with the fact that it's a transmission line and not just effectively like lumped elements. The problem is that I don't understand transmission lines very well either. If this is wrong, I'm gonna blame David Freitag, because I don't know. To be fair, he was helping, and I have no damn clue what the hell was going on. So yeah, I'm maybe just like misunderstood or something. But for now, I'll just design it like this. But I think what I'm gonna end up doing is yeah. Let me see if I can find a link to where that is. It's quite a long conversation, but let's see if I can find where the conversation was. It was in reply to one of these. Oh no, it wasn't. It was into this, I believe. So yeah, here's like the there's the root of it. Oh, did this just catch your I may have caught your message as like a link, but I can't remember how to get to the, is it under moderation? It may be under moderation, but I cannot see where that is. Oh, now I've lost the, so I think actually if I open up, oh no, I appear to have lost. Where's that gone? Yeah, unfortunately I appear to have accidentally closed a thing. I'm in the stream manager, but I don't see the thing of like yeah, I don't see the thing of like auto modded. Yeah, anyway, I'm not going to faff about with that for now. I'm going to carry on with this, and then it's quarter to 1 in the morning here, so I'm going to be going to bed fairly soon. But yeah, so I might change these later if that's wrong, but yeah, I will at least assume that it is correct for now, even though it may not be. Yeah. So that's all the inputs. Then on the outputs, see, this is where it always throws me slightly, because yeah, it's still supposed to be terminated on the transmitter side, right? It's also supposed to be on the I always forget how this worked. Yeah, I think it's supposed to be on both ends. Because then any signal reflections coming back hits that. Yeah, here we go. But I think is that not only for, yeah. I was never sure whether it's, because it's half duplex, I was never sure whether the terminating resistor on the near side is only there for signal reflections coming back for a driver sending data back. Yeah, it is multi-drop. Yeah, so if I'm only sending data in one direction, I don't think I actually need the terminating resistor on this side. What I am going to do is I'm going to put a footprint in for one, because otherwise it'll screw me. So effectively what I'm doing is taking exactly this, yeah, the more I think about it, the characteristic impedance thing doesn't make any sense to me. Like, how do you have a line that always has 100 ohms characteristic impedance? You can't. It's not a thing. Like, if it's variably long, that doesn't make any sense. That's what's basically been making me scratch my head for the last 48 hours is, yeah. But surely the impedance of a line changes depending on how long the line is? Confusing. By the way, is my microphone like really noisy when I'm not talking? Is it just like, because that looks kind of loud. Like, I think I may have accidentally like messed my mic settings up and stuff, but oh well. Okay, the mic's good. No, that's always good to know. Right, anyway, yeah, I think I'm going to have to look into this a bit more, because I don't think that that's quite right. Now, the more I think about it. And the other thing that then would be changed is that it's like what it would be P equals V squared over R, and then R would be 120 instead of 20, which would bring that power way down, and then the quarter watts would be fine. So yeah, I'm not sure. My brain. I think this is one of those things where, like with the impedance thing and the termination, I'm gonna have to sit down and like really I'm far too tired to think about it at the moment. As I said, like last 48 hours I've had 10 minutes to sleep, so let's go to out 1A. Oh, why am I doing it that way? And out. Cool. And then in this particular case, the also I just realized that this is A3. I would prefer it to be A2. And then I can take all of that, move it all up. Yeah. And then move this up. Oops. And then later what I'll do is I'll box all of these into, you know, individual parts with a thing saying, you know, this is what this is and this is what that is. And the reason I'm moving all this around is because, oh, excuse me, this needs the DC bias resistors. These do not need to be quarter watt, so they're just going to be standard Reso 3s that I've bought in, and I'm just going to do the same thing again of turning off the comment. It's the only thing I care about. And then, and if I remember correctly, they're not the same value on both sides. Like one is supposed to be, I think you can have them at the same value, but I think they're not normally. I think it's oh no, it is 560, 560. Yeah, I know I can use hierarchical design. To be honest, I need to sit down and figure out how all the hierarchical design stuff works. I haven't managed to like sit down and look at it properly. So yeah, then we get a bias resistor here, a bias resistor here. Okay. Okay. So what I'll do is I'll put the parts in, but I'll mark them as DNP, and that way I know not to populate them. I think there is a thing for just marking something DNP, but I don't remember how to do it. There's a thing on here. I know there's a no ERC. Variants? Okay. Ah, yes, variants. Ah! Cool. Thank you. That's awesome. Didn't know that. Right. Yeah. I get it. Although, all of my parts are called like R question mark. Right. I'm confused. Is this not the graphical way? Yeah, add variant. Okay, what am I naming this? Just like DNP? Oh. Okay, default. What did that do? And then again, and then DNP, I guess. No. Oh, click OK on the variants window. Yeah, I see the default variant. Double click. I'm on that. Oh. Aha. Awesome. DNP. DNP. Thank you. That's cool. Didn't know you could do that. And then I guess when you create different variants, you basically set the DNP state for each part in each variant. So if you're making multiple boards... Yeah, exactly. Yeah, okay, that makes sense. So it's like if you were making, say, like a motherboard that had 3 different variants, and then and then in the output job you pick the variant. Right, that makes perfect sense. Gotcha. I knew it was a thing you could do, I just didn't know how to do it. That is very helpful. Thank you. Yeah. Perfect. That is very, very useful. And then, of course, I need to go there and DNP all the others, but that's fine. And then these go in here. See, I've done the way I did it before. I've only ever done it once before, and that was I added an attribute called DNP, and then when I generated the BOM, I filtered out the ones that had that attribute, and then did the same on the pick and place, so that they weren't that they didn't show up in the outputs. But it's much more laborious to do it that way, definitely. Whereas that is really nice. I'm glad I know how to do that now. Thank you. Cool. So those are all the outputs. I'm getting there. So we just need the decoupling, which of course I have the parts for that already somewhere in here. There we go. Oh, do I have one that isn't tiny? Like really tiny? Oh, no, I don't even want that big. Yeah, so instead of using 100 nanofarads, I'm actually going to use 470 nanofarads because I'm lazy, and the 0.1 microfarad caps that I have are 0402s, and I would prefer not to have to deal with 0402s for this. Not because I'm, hand soldering. Not because I'm hand soldering them or anything, because it's going through GLC. They're doing their own fab for it, but I would prefer not to use like really tiny parts when I don't need to. An 0402 is just kind of like a little bit too close to, because they're pad to pad tolerances, like their clearances on pad to pad is just slightly larger. In fact, it's almost like if you use the IEC compliant footprint for 0402, technically speaking, the pads go slightly too close to each other, and you have to then edit them to basically sit ever so slightly further apart, so that they'll go within the manufacturing tolerances. So yeah, I would rather stick with those 603 in this particular case, and larger. So, oh, did I put these in as? Are these also 0402s? No, I put these in as like cap semi. So in which case I'm gonna have to go and fix these later anyway. So it doesn't actually make sense for me to include that one. I'll just swap these all later. So I need 8 of those because, wait, is that? Yeah, I thought so. There we go. 1, 2, 3, 4, 5, 6, 7, 8. So those are all the decoupling caps for the ICs. So they will go to VCC. And they will also go to regular ground. Oops. So obviously these are all for decoupling the individual ICs, and they'll be very nicely placed next to each other. Excuse me. Then I need a 2-pin. I might use 4-pin. Not because I need 4 pins, but because it's useful to be able to tap onto. So this is going to be for the voltage input. So this is just power for the board. And I kind of like doing this as like voltage, ground, because if you then only plug it into the middle two as like voltage and ground, you've got a spare 2 pins on the outside that you can actually use just like DuPont connectors to plug into, and it's just useful. So let's take VCC, put that up here to ground, put that down here. There we go, that's power. What I might do is, just for the sake of it, is under my parts library, I have some... Yeah, I think that'll do. There we go, and then that is good enough. Cool. It's probably not the 10 microfarad ceramic's probably not even necessary, but for the tiny cost, why not? Cool. What else was I going to do? So technically speaking, I believe, what was the so this, I know it says 5 volts only. What's the minimum voltage that was on here? I can never remember what the voltage is supposed to be. Here we go, VCC plus 7. Yeah, I know, but that's not useful. I want to know what the minimum voltage is. Here we go. So it must be at least 4.75 volts. So I don't think I can quite get away with sticking a polarity protection diode on that VCC input. Because if it needs 4.75 volts, 250 millivolt VF, yeah, perfect diode. Like, even a Schottky I think is probably going to be too much. Oh, that's an ESD diode, I don't care about that, yeah. Yes, you could use a FET, an NFET, sorry, PFET rather. I've got a, believe it's this one? Yeah. I've got a PFET in there. And if I remember correctly, it's been a while since I've drawn this out. Yes, ideal diode, yeah, I know what you mean. So yeah, I could do this, and I believe the way it's supposed to work is this. It's been a very long time since I've drawn one of these. I believe it's supposed to be... This is actually backwards, isn't it? Because I've done this the wrong way around. Oops. Let's draw this the right way. Because VCC is on the right. Oops. So this is here. And then this is... Flip this way. So that goes like that. And then this comes down and is ground. Yes, I think. It has seriously been so long since I've drawn one of these. Yeah, I'm pretty sure that's it. PFET reverse polarity. You can see I've searched for this before. Oh yeah, and then you use the clamping thing, and then it's 100k down to ground. I forgot about that because you're supposed to use a. Yeah, exactly. So you're supposed to use the Zener diode to clamp the VGS within range, but I think these, I think the AO 3401, I believe the max voltage, I believe VGS max is actually greater than 5 volts on this. It's VDS, yeah, VGS is like plus minus 12. Yeah, exactly. Am I right in... No, actually, I'm wrong in saying... Yeah, because so you don't need the resistor in there in this case, right? Because the resistor on here is only used because you want to limit the current flowing back through the Zener when it's clamping, if I remember correctly. Yes, okay. So that should just work. Yeah. See, I'm glad I can build those from memory. It has literally been about 4 or 5 months since I've drawn that. Okay, that's looking pretty good. What am I missing now? So I've got all my TVS. I've got all of my... Obviously, these need potentially sorting out. LEDs. So we're talking what? 2.1 VF, if I remember correctly. I believe the forward voltage is 2.1. Yeah, typical 2.1, 2.2-ish. So it's like what? 5 minus 2.1 divide 0.02 2 because it's 20 milliamps, so it's 145 ohms. So if I go slightly above that, 100 and it's the nearest in the, is it 150? 150 is a standard size, yeah. Right, cool. Take it easy. Yeah, I'm gonna head to bed in a minute anyway. I think I'm just gonna get these LEDs hooked up and then head out. So yeah, cheers for hanging out. So I will just get this done quickly. Yeah, I don't know why it's caught that. It's not showing me any of the caught messages, so I'm not quite sure why. Well, that's irritating. But yes, you're all good. I don't appear to be able to like undo that either. I'll have to try and find out why that's happening. The links to some common resistor values. Yeah, I think I need to add you to the like the link, the approved whatever. The approved link people. Whatever that means. Yeah. I don't know. I'll have to look later. Right. Night. I will catch you later. So let's get this. And thank you very much for your help. So yeah, the next thing I want to do is I'm actually going to just delete this and redo it because it's getting in the way. There we go. That seems okay. So that's the shielded part, and then I'm going to move this over here. Oh, that's really irritating. Oh well. So that's ground, and then these just need to go up to a resistor each. So then let's just take one of these random who cares resistors. Put that here, and then here. So that's 150 ohms a piece, I believe. And then let's fix this. Oh wow, that went weird. What on earth is going on there? I swear moving things around in Altium is just cursed. Just very weird things. I'll tidy all this up later because it's fine. Who cares? So yeah, let's move these over here. I guess this one can go here or here. So then this goes up like that, and then this goes up like that. And then in both cases, these just go to VCC. Cool. So it's untidy, but I think that is technically correct, which is the best kind of correct. So yeah, I think I'm going to call it at that because it is now 1:10 in the morning and I am absolutely exhausted. So yeah, thank you all for hanging out. I will probably be back streaming tomorrow night with any luck. Fingers crossed, because I want to do the PCB for this. And I also need to find out what the hell's going on with these resistors. I think I'm probably going to end up switching these out for 60 ohm ones because I think it is actually supposed to be 60 ohms. Now I'm thinking more about it, but I'm probably just second guessing myself. So yeah, but the PCB needs doing, so that's going to be fun. I'll tidy up a bunch of this off stream, and I will get these the parts that are supposed to be specific parts. I'll like import those and everything and get all the parameters in and do all of the busy work that's not that interesting to watch on stream, done ahead of time. So hopefully it'll be a bit more interesting. But yes, in the meantime, that's everything. So good night, and I shall see you all soon.